Hello guys, and welcome back to another episode of chemistry. And of course, in this episode, we are going to be continuing our study on aldehydes and ketones. Actually, it's a concluding episode right to aldehydes and ketones. So we are seeing tests for carbonyl compounds. The carbonyl we're talking about here is just aldehyde and ketone. Please do not use this test for carboxylic acid. Do not use them for esters. Do not use for thioesters. Do not use them for acid halides. Do not use for acid anhydrides. Do not use them for amides. Okay, it's only for what? For aldehydes and ketones. All right, please do not use them for the other carbonyl compounds. Okay, now this question from the O3SCHOOLS JAMB app. By the way, this tutorial is brought to you by the O3SCHOOLS JAMB CBT practice app. We will talk about the app in a moment. Let's just see a question from the app. A 2023 question number 37. It says, which of the following reagents can be used to distinguish between an aldehyde and a ketone? All right. So which of the following reagents can be used to distinguish between an aldehyde and a ketone? A says Fenton's solution. B says Tolling's reagent. C says Benzene reagent. D says Mucas reagent. All right. So we will come back to this question at the end of the class because we believe in giving you value first before answering questions. Let us teach you first so that you go know. Once you know, answering question will be the list of your problems. All right, so please do not forget to download the applications. The O3SCHOOLS app has all you need to succeed in your exam, has all the past questions for your exam, okay, for all subjects, all right, in one application. Then what's more, lecture notes structured according to the JAMB syllabus, so there's no need for you to be worrying about textbooks. And what's more is that there's question search feature, and then the bomb, which is UTME mock challenge. This mock challenge is a challenge that will conduct for all students that are writing JAMB for this year. You compete with your mates, get used to JAMB past questions, get used to JAMB likely exam questions, see your result released every Saturday, thereby building your confidence toward the main exam. The app is a compendium of sources. See our testimonies and see that the Lord is good. All right, so please download the application and activate it. Activation is just for a little token. Make sure you pay the sacrifice and activate. All right, so now let us see test for carbonyl compounds. So we want to test for this group, C double to O. All right, carbonyl compounds. Compounds having this group in their formula, but specifically in this class we're talking about the aldehydes and ketones. So anything we talk about here is for aldehydes and ketones. Do not include the other carbonyls. So all right, so now let us continue. So for us to test for carbonyls, all right, so especially an aldehyde or a ketone, what to use is called 2,4-DNP. Okay, we'll call it 2,4-DNP. Some people will call it 2,4-DNPH. All right, but the full meaning of this is not really necessary. But let me just tell you, make it not be like say me no teach you. Okay, you can use it to do buga. Okay, for your friends. What is this? So if you just know 2,4-DNP is enough. Okay, but the full meaning there is 2,4-dinitrofenyl hydrazine. 2,4-dinitrofenyl That's the full meaning of 2,4-DNPH. Simple as A, B, C. Okay, so now this 2,4-dinitrofenyl has a structure. The structure is also not necessary. I just want to show you for showing sake. So you have your benzene ring, all right, with alternating double bonds. Okay, then you have your nitro group on this second point. Your nitro group here also NO2. All right, then here you now have your nitrogen bonded to an hydrogen. Then this nitrogen bonded to another nitrogen, bonded to an hydrogen and another hydrogen. So this is the structure of your 2,4-dinitrofenyl. Okay, this 2,4-dinitrofenyl is also called Brady's reagent. Brady's reagent. So you may not see 2,4-DNP, but you may see Brady's reagent. So you can just commit that to memory. All right, so now, how do we use this to distinguish? Okay, to test rather for carbonyls. So once we use this reagent in a solution containing either an aldehyde and a ketone, we will observe an orange precipitate. Okay, an orange precipitate will be observed. Okay, so once this reagent is put in a solution containing either an aldehyde or a ketone, any of them, okay, we will observe this orange precipitate. This is the positive result that shows that there is a carbonyl present there, okay, and it is either an aldehyde or a ketone. That does not distinguish it. it does not distinguish that it is actually an aldehyde. You cannot beat your chest and say it's actually a ketone. Okay, it's just for you to, it's just to tell you that either an aldehyde or a ketone, all right, but it does not tell you that it is actually an aldehyde or a ketone. But if you want to use this test to further distinguish whether it's actually an aldehyde or a ketone, what you do is that you carry out further tests from this orange precipitate that you have seen. So what do? The first thing you do is that you filter this orange precipitate. So once you filter this orange precipitate, the next step, the first step, let me put the steps down because they are just for clarity's sake. For clarity's sake, number one, what you do is that you filter the precipitate, the orange precipitate. Once you have filtered it, number two, you recrystallize it. And the reason why we recrystallize is so that we have a pure solution of the compound. All right. Then after we have recrystallize it, number three, what you do is that you determine the melting point. You determine the melting point. Once you have determined the melting point, what you do next, number four, is to compare the melting point, this result you have gotten, compare with database values. So there's a database that have all the melting points. They have melting point of the ketones and aldehydes. So you compare the result you have gotten with that database values for you to be able to distinguish whether it is actually an aldehyde or a ketone. All right, so that is the first method we use to for the testing for carbonyl and distinguishing between a ketone or an aldehyde. So we say it's 2,4-DNP or 2,4-DNPH, all right, and it's 2,4-dinitrophenylhydrazine, also called Brady's reagent, and the positive result is that we observe an orange precipitate. So please commit that to memory. Now let us see the second method you can use to test or to distinguish between an aldehyde or a ketone, and that second method is called silver mirror test. So number two, we have silver mirror test. Okay, this silver mirror test, the reagent that we use is Tollin's reagent. Okay, we use Tollin's reagent for this silver mirror test. And what is Tollin's reagent? We have talked about Tollin's reagent before, and of course, Tollin's reagent is It's actually ammoniacal silver trioxonitrate or ammoniacal silver nitrate. All right, so and it is actually AgNO3 plus NH4OH. This is our Tollin's reagent. Okay, and it is very important to know that this Tollin's reagent will only give a positive result for aldehydes. It will only give a positive result for aldehyde. It does not give a positive result for ketones. It only gives a positive result for For aldehydes. Now, what happens? And why does it only give a positive result for aldehydes and not ketones? Okay, what happens is that this Tollin's reagent, okay, this AgNO3, all right, has or fashions what we call silver ions. Okay, this Tollin's reagent has silver ions, and what happens is that the aldehyde reduces this silver ion to to silver solid. Okay, so how does it do that? Plus one negative electron. I'm going to have now? Ag solid. Okay, so it reduces the silver ion, the aldehyde reduces the silver ion present in the Tollin's reagent to solid silver. This solid silver is actually the silver mirror that we observe. All right, so this is actually the silver mirror. Okay, which is observed as a result of the reduction of the silver ion to solid silver. Okay, so this is the positive result. So the positive result that we observe using silver mirror test is that the silver ion is reduced to solid silver, and the silver mirror is what is observed. But this does not happen with ketones. So you must take note of that. And why does it not happen with ketones? The reason is that that aldehydes can be oxidized. They can be oxidized to carboxylic acids, but ketones cannot be oxidized to anything. So take note of that. So this is the reason. The major reason is that aldehydes can be oxidized to carboxylic acid, but ketones cannot be oxidized. So take note of that. So this is the second test we do to distinguish between an aldehyde and a ketone. Silver mirror test using Tolling's reagent. Okay, and the reason why we observe a silver mirror with aldehydes is that because the silver ion present in the Tolling's reagent is reduced to solid silver. Okay, so that's the second test. Then the third test we are going to used to distinguish between an aldehyde and a ketone is Fehling's solution. Fehling's solution. So number three now we have Fehling's. Okay, sorry, Fehling's solution. Okay, so this Fehling's solution is a complex compound. It's a complex compound of Cu2+. Okay, Fehling's solution is a complex compound of Cu2+. So when an aldehyde compound is treated with Fehling's solution, what happens is that this copper ion is is reduced to copper or solid, or to solid copper. Take note. So when an aldehyde is treated with Fehling's solution, this copper ion present in the Fehling's solution is reduced to solid copper. So here, of course, plus 2 electrons will give us copper was solid. Okay, and of course, what happens? We observe a red precipitate. A red precipitate is is observed. A red PPT. Okay, is observed. This is the positive result. Okay, this is the positive result that we get with Fehling's solution. We observe a red precipitate. Please take note of that. We observe a red precipitate with Fehling's solution. And of course, this only works with aldehyde. Okay, so this is only positive for an aldehyde. It's not positive for a ketone, only an aldehyde. So when you are thinking maybe this is an aldehyde, a ketone, can use Fehling's solution. If you observe a red precipitate, then you know that it's an aldehyde. It cannot be a ketone. So please take note of that. So this is the third test to use to distinguish between an aldehyde and a ketone. Then the fourth one and the final one we're going to consider is using chromic acid. Number 4 is using chromic acid. All right, so please, before we continue, if you have not liked this video for any reason, all right, what you are doing is very, very wrong. I stand here to tell you that what you are doing is very, very wrong. So please click on that like button, because liking the video, just only liking, all right, we allow other students who are looking for this video to easily see them, to be recommended to them. All right, so please like the video. Do not forget to share on Facebook, share on YouTube, share on TikTok, share on all social media platforms, WhatsApp group. Let everybody keep learning and succeeding together. Okay, I don't think that is something too huge or too big for you to do. So please, before you continue this video, you can do that immediately so that you do not forget. Okay, so using chromic acid. Also, aldehydes react with chromic acid. Aldehydes react with chromic acid, but ketones do not. Okay, so take note of that. It's another test. Fourth test, aldehydes react to chromic acid, but ketones do not react to chromic acid. And what do we observe? The positive result that we observe here is is a green to blue precipitate. Green to blue precipitate. Okay, so either green or blue precipitate is observed. Okay, when we are using chromic acid to test or to distinguish between an aldehyde and a ketone. All right, so the presence of green to blue precipitate confirms the presence of an aldehyde, not a ketone. All right, so that's the fourth method we learn to distinguish between an aldehyde and a ketone. So now what we do is that we'll go to the O3SCHOOLS JAMB app and we'll answer the questions that we have searched using the question search feature. Okay, so what we do is that we'll go to question search feature on the app menu, then go to chemistry, then search for aldehydes. We search for aldehydes or search for ketones. Use any of the keyword, okay, or search for organic chemistry. Questions under organic chemistry will come out for you to answer. All right, so that's what we did here. We search for aldehydes and these questions are out. So this is a 2023 question, number 37. Which of the following reagents can be used to distinguish between an aldehyde and a ketone? A, they say Fenton's solution. Very wrong. B, they say Tolling's reagent. Did you talk about Tolling's reagent at all? Yes, so very correct. C says benzene reagent, very wrong. D says Mukash reagent, very wrong. So our correct answer there will be what? Will be Tollens reagent, option B. All right, so let us see another question. This is 1997 question number 48. 1997 question number 48. They say, choose the correct answer from the options above. All right, it says that when failing solution is added to two isomeric carbonyl compounds, X and Y, with the molecular formula C5H10O, they say compound S gives a red precipitate. Okay, failing solution. Compound X gives a red precipitate. Y does not react. It can be inferred that X is what? S is definitely an aldehyde. So that's the first thing you need to first know. Okay, we have talked about using failing solution, and we'll talk about what the fact that the only aldehydes give a positive result, and a red precipitate is what is observed. Okay, so now we already know it's an aldehyde. Among the options, which of them is what is an aldehyde? You can see option A. Option A, so let us just distinguish. Let us draw all of these structures out. This is CH3, C double bonded to O, CH2, CH2, CH3. Okay, so now, is it possible in this world, okay, that this will be an aldehyde? No, okay, because we're having what? A carbonyl present in the middle, not at the beginning or at the end. That means that what? This is a what? It's a ketone. If you followed our classes, this should be very easy for you to understand. All right, so then these are the second option, said CH3, CH2, 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 C double bonded to O, then H. Okay, is this an aldehyde or a ketone? Obviously, this is an aldehyde because the carbonyl is present what? At the end. Okay, at the end of the chain. Okay, it's present at the end of the chain. So for that reason, this is what? An aldehyde. C says what? C is definitely what? A ketone, because you can see it's not at the end or at the beginning. D is actually what? A ketone. It is not at the end or at the beginning. So our correct answer there will be what? This will be this option, which is what? Option B. Follow our classes. We're not forcing you, but they are helping you, whether you like it or not. So let us continue. 2015 number 22. It says failing solution can be used to distinguish between is definitely an aldehyde or a ketone. So let's look for the option that has an aldehyde or a ketone. A is an aldehyde and an alcohol, so it cannot be. B is a ketone and an ester, cannot be. C is an aldehyde and a ketone, very correct. So our correct answer there will be what? Option C. D is an alcohol and a carboxylic acid. So now this is a 2023 question number 37. Okay, we have looked at this. I looked at this question. All right, so this is a 2008 question number 40. 2008 question number 40. They say, if the silver mirror test is positive, it indicates the presence of what? It's definitely an aldehyde, okay, which is what? An alkanal. That's our option what? D. A says alkyne, B says alkanol, C says alkanone, D says what? Alkanal. Alkanal is very correct. All right, so there are thousands of other questions on this application. Jump on the app, download it, activate it, recommend it to your friends, your family, the witches in your family, your enemies, recommend it to all of them. Let all of them pass and succeed, okay? So please, you owe it to people to succeed. Make sure you keep telling them about the O3 School Jam. My name remains Master T. I am the Grand Commander of this O3 Schools Army. All right, I'll see you in the next class where we'll talk about esters. Thank you for watching.